There we go. Let's talk about some things that have happened. What's happened? I started grading things in Canvas. I did not get far. Just so you all know, there are 2 class sections that meet at this time. The college wanted, there were so many people wanting to take 130, the college created another section of it. And I agreed to add it to my teaching load. So there's the 130.I3. You can see that up here in the corner, that section, and then the 130.I4 or -I4 section. So I don't tend to know and hear who's where. And you don't know per se who's where. So like if you're wanting to get together and if you're wanting to talk with each other outside of class, you may discover, you already did, some people already discovered that one person was in one class, the other was in the other, and you don't really have ways in Canvas to email each other. So feel free to send me an email if you want to connect with someone in the other class to work, and I would be happy to forward it on and get your contact information figured out. And the same line or thinking, I started grading the I3 worksheets. And there's 30 people in there, and I think I got like through 15 of them. So I have started grading. If we think about due dates, I guess I'm not super far behind because the first due date was the 11th, which is Sunday. So I'm only, what, 3 days out? Oh, I'm feeling so good. But if you look at how many things you had to turn in, it's 3 worksheets. So I have 3 items to grade. And then this coming Sunday, you're turning in the 1-4 worksheet stuff that we did last time, and depending upon how far we get, the 1-5 and 1-6. Before we go any further, I want to also note that there is a new module listed in here. It's the project module, and that is the big project. So let's start by talking about the Unit 1 project. Now, I think folks have been emailing me about not being able to write on the documents in Canvas, and that's because you need to download it. I don't know that there's a way for you to write in this preview thing. Plus, this one says there's a bad gateway. Let's see if it shows up now. Service is currently unavailable. Well, whatever, I'm going to click download and see what happens. Here we go. It's opening it as a Word document. That's what you'll have to do to, I believe, to work on any digital things. If I'm wrong, awesome. If you figured out how to write on things in another way, good. So here's this project. First thing, this is me testing you, right? So this is in replacement of exam, and this is things I want to see that you learned from Unit 1. They need to be unique, so please don't submit someone else's work or share work. It's totally acceptable for you to work together. You can ask me questions, you can talk to your friends, tutors, instructors, but you can't submit identical work. That's going to be deemed plagiarism, and I guess I would have to do something that I don't want to have to do. All right, so what are you doing in this project? Well, the first task is to write a weekly schedule. Now, I've put some guidelines in here, the top 5 to 10 uses of your time, like broad uses with some examples. Please do not think those are the ones you have to use. This is full creativity. Do what's useful to you. And what I think talked about when we did lesson 1-2 is that a great place to do this is Excel or Google Sheets, or if you're a Mac user, the numbers worksheet. Just be careful if you submit, you'll have to save the numbers thing as a Excel, because I don't have a Mac. I can't open Mac documents. So in here, maybe you're doing the days of the week across the top as columns. Nope. And then down here, maybe you're doing military time, 0, 1, 2, 3, up to 24. I think that's how military time works. So this would be a time slot of 1 hour apiece, and you could create your weekly schedule in here. It's up to you. I'm not telling you how to do it, how it should look. You could put the rows of things, whatever. And you're just thinking about, here's how I want to spend my week. This is the ideal way for me to spend my week. And then you're going to create that table, and then you're going to add up the number of hours you're spending in each category. And creating some bar graphs and pie graphs like we did in that section. And then the second part is you're going to track, you're going to pick one of those categories, and you're going to track your weekly usage. How did you actually spend your time? So if we're learning about this concept today, relative error, here you're estimating your time usage. Here you're tracking real-time usage, and you're going to do some calculations to see how far off you were. You'll create some more little things and do some analysis. Note that the analysis here is a pretty important part of this. So put some thought in here. This is kind of the math things. And then when you're doing this analysis, you are talking to me about your calculations. You're explaining them and how they affect your understanding of your time usage. And then finally, here's the one from 1.4. You've got a dimensional analysis question to work on. And the first thing you're going to do is write down someone's weight in pounds. I didn't want to ask for your weight in pounds because that seems really intrusive, but you could certainly use your weight, or you could make a weight up. It's whatever you want to do, but it needs to be an amount in pounds. You're then going to convert it to kilograms. You're then going to find your favorite fast food meal and look up how many carbohydrates are in this. You're going to share your source for that. I give you a prompt here about insulin and carbohydrates. This is kind of like the lesson check question we did in 1.4, and you're going to do some calculations there. Now, when I say show your work, that can be this. You go to Desmos and you type in your stuff. So maybe you record someone's weight as being 180 pounds. And you wanted to convert that to kilograms, and you know that 1 pound is 2.2 kilograms. So you would do this, or is it 1 kilogram equals 2.2 pounds? That actually sounds more correct, doesn't it? And this could be your work. If you want to screenshot this in Word, you do this insert and screenshot, and then do screen clipping. And then you just clip this little piece where you did your work, and there it pops in there. That's perfectly acceptable, showing your work. If you would rather write on a blank piece of paper, I took the 180 pounds and I multiplied by 1 kilogram divided by 2.2 pounds, and that's equal to 81.81 repeating, that's fine too. All right, I just want to make sure you're aware of what it means to show your work. I'm almost more interested in your work than your answer, just so you know what happens when I'm grading. Okay, so that's the project. What you need to put in your heads, sometimes students have a hard time wrapping their minds around this. This is your exam, and this is one of the most important assignments in this class. This represents 12% of your grade. It goes into a category that's 50% of your grade. Take your time on this, do a good job, don't rush through it. This is more important than the lesson checks, the homework, or the ALEKS work, and even more important than the midterm. Okay, so that's that. Any questions on this project? All right. So let's do lesson 1. Oh, wait. When is it due? That's a wonderful question. I have no idea. Let's find out. I believe I made it due Yes. So this is one of those ones that here's my experience. All deadlines are soft deadlines in this class. But the students that don't turn in the projects by this quote soft deadline tend to not do them. You know who you are as a student and how you function and what works. So, take care of yourself and do, make sure you're doing how you do things. But just a heads up, that's my experience. Students that don't turn it in on time, on the scheduled time, don't tend to get it done. Because the project's going to be due, currently it's set for September 25th. So you have the rest of this week, all of next week, and then it's due that Sunday. I may need to push it one more to the October 2nd. Just probably not, but I can. But my fear for students is if you don't do it, we're all into the second project, the second unit, right when this is due. Actually, we start the next unit, and this is due the week after we start the next unit, I believe is how it's scheduled. So it can easily snowball, and then you get into trouble. So I just want to throw that warning out to be careful. But yes, it's a soft deadline. If you need more time, take more time. Usually the students that don't turn it on the soft deadline never started it, never did it. And so lots of times those are students that are never going to end up doing it for whatever reason. No judgment from me. I just have to record that result, which isn't fun for me, but it is what it is. Any other questions about the project? We're certainly going to talk more about it after we're done with the whole unit, which is just 2 sections away, this section and the next one. Okay, so today we are looking at relative change and percent error. And there's nothing new here. We've already done this. We're just going to put some different clothes on percent change. We're naming it a little bit differently. This is an interesting quote. I don't know how well it has aged. Mr. Einstein, when you sit with a nice girl for 2 hours, you think it's only a minute. But when you sit on a hot stove for a minute, you think it's 2 hours. That's relativity. So relative change is comparing the amount of change to original amount. And here's our author likes this example. He says, let's say I owe you $20 and I only give you $10. How happy are you? Is that okay? So he borrowed $20. A week later, he comes back and says, here's your money back. It's only $10. And then the second scenario says, well, what if you win $5 million in a lottery, but you get paid only $4,999,990? Would that ruin your day? And then he points out, so in both scenarios, you were shortchanged $10. By the way, his scenario is a little bit ridiculous because if you win $5 million in a lottery, the government's going to take 30 to 40% in taxes, right? So you're not going to get the 4 million, but whatever. Let's say you win 5 million after taxes and they shortchanged you $10. And then his argument is it's a bigger deal when the amount is $20 than when the amount is 5 million. So we want to make sense of that. How cool is Einstein's hair? Mine's cooler, right? Come on. So anywho, here's the formula for calculating change. Now, we haven't talked about this one before. This is an amount. You did it in the 1-1 worksheet. I was grading it just today, and some people nailed this part, some people missed it. I think it's because we did the 1-1 worksheet in class, and we talked about it, and the folks that were able to view that had a good understanding of it, and folks that weren't able to view it might not have had it as good. I don't know. And change is just how different are two things. Change between two quantities is the subtraction. So I like to write that formula as just new minus old. Take out all the extra words and then you have it. Whereas relative change, Oh, note, he says we can also call this actual change. How far apart are these things? And then relative change is the change divided by the original value, meaning what percent change is there? I, again, like to write this as new minus old divided by old. I think it's really important that students understand that this is a decimal. When I was grading the worksheet, some students weren't understanding that quite right. So make sure you make that clear to yourselves. So if we want it as a percent, we have to multiply by 100 to turn it into a percent. You can use his algebraic notation, this subscript notation, xn minus xo, x subscript, that just means, that's just a fancy math way to write things in letters. It's great. But notice this is no different than the percent change formula. It's exactly the same. We're just now calling it relative change. So this is the same thing as percent change. And then we're adding in that we should think about how much change is there and then what percent change is there. So the author leads us here and says, look, our first scenario, the relative change would be calculated this way. So what our author is saying is that if he pays you $10 off of the original amount that they borrowed of $20, we define the 10 as the new, the 20 as the old. And when we do this subtraction, like he's got written here, we get that you're shortchanged $10, and relative to the 20 you were owed, you're 50% off. So 50% of the amount of money you were owed wasn't given to you. That feels bad. That feels like a big deal, I guess. It depends on your relationship with money, right? Have you heard that expression, or that it's not worth Bill Gates' time to bend down and pick up a $100 bill? You know, because that's pennies on the dollar to him. Like, often people won't pick up a penny. I saw one the other day. I looked at it and I thought, oh, I could pick that penny up, but I didn't, because I wanted to get to my car, because that penny was making no difference to my financial security. So even this number is a really relative number compared to how much money do you currently have. So I want you to try this one. It says, find the relative change if you win 5 million and get $4,999,990. And we're supposed to write that as a fraction, not a decimal. Here's my hint: do new minus old divided by old. And I'm going to say that this 499,999,000 is the new value, and this is the old value. And while you're doing that, I'm going to get a cup of coffee. It's just my third cup. It's okay. Okay. How we doing? Anyone got the answer?
I don't understand this. Like, I calculated it out and the answer is -2e -6.
Nice. So when you say you calculated it out, you wrote it as a decimal, which is totally fine. He wanted you to leave it as a fraction, which.
Oh, okay, gotcha.
But we need to talk about that. So yes, that's a thing we need to know about. And I'm going to argue that this fraction is not very useful in terms of our understanding. One thing, we can simplify it a little bit by canceling these zeros, and we get -1 over 500 thousand, right? That's the fraction. And we compare that to the other fraction. So here he says, compare the relative change for the two scenarios. Does this match our intuition? So when we were shortchanged 10 out of $20, it was negative 1/2. When we're shortchanged 10 out of $5 million, it's negative 500,000. Well, let's do what you did, Maya. Let's get the decimals. In fact, I think that's what he wants done. No, he doesn't want it done. He never asked you to do it. Let's do it. So I'm going to pull up Desmos. And I'll do the -1 divided by 2. And then I'll do the negative, ooh, easy there. -1 divided by 500,000. Now, Desmos gave me all the decimal places here. Maya, what calculator were you using? Was it your cell phone?
No, it was TI-84.
Oh, okay, okay. Yeah, that's cool too. I don't know why you're stuck in the 90s. Or is that 80s? When is the TI? No, those are, we used to use those calculators all the time. I am such a huge fan of Desmos. It's just so nice and pretty.
I'm not that much younger than you, so that's why.
Yeah. No, I lived that life. So here's this, right? If we wanted these as percentages, which in some cases I think is easier to understand, we'd multiply each of these by 100. So those are percents. Let's compare them. But first, let me write them with their percentage signs. So this one, the 1/2 is exactly -50%. This other one is exactly -0.0002%. Talk to me about those two percentages. What do y'all notice?
I still don't understand how you got to -1 over 500,000.
Oh, got you. Well, thank you for saying that. Let me go back. So what I did is right here, I divided the 10. I divided both the top and bottom by 10. And what I really did, which was really mean of me, is I used a trick that I learned a while ago that says if you have zeros and tops and bottoms, you can just cancel them out. Kind of like what we were doing with the dimensional analysis, where it was like, if you had miles in the top and miles in the bottom, you divided them away to 1. That's really what happened here. But maybe Mike, I should say, were you good from this piece to here?
Yes.
And then does that make sense now what I did, how I went from the 10 over 5 million to 1 over 500,000? Is that better?
Yeah.
Okay, good. And then we're down here and we're trying to understand, or we're trying to use these numbers as like facts to talk about why are we pissed that someone shorted us $10 out of 20 and we might not care about someone shorting us $10 out of 5 million. What's the argument we can use here with these numbers? And maybe let me frame that question a little better. What is this percentage approximately equal to?
Like way less than a cent.
Yeah, I mean, like it's like this is essentially 0. So relative to the 5 million, not being given $10 is approximately 0% of the money. Whereas not being given $10 out of $20 is roughly 50% of the money. That feels like a big deal. If we were to take 50% of 5 million, if we wanted the relative changes to match, we would have to be shortchanged 2.5 million. So 2,500,000. That's upsetting. I also get like, I'm never going to have that much money at one time. Maybe when I die, I will have made that much money. So thinking in terms of multiple amounts of millions can also be challenging. But this is how a mathematical way to think about change between numbers, differences between numbers, looking at the relative difference between the actual difference. Actual difference in both of these is the same amount. The relative difference is not. It's very different. So this is the actual. Okay, let's see what you think about this. So let's pretend I tell you that I'm going to give you 2 extra credit points on a recent test or quiz. And you are to tell me, thinking through the lens of relative change, when is this super good news and when is it not very helpful? And maybe I should ask, would this ever feel like good news to you? Well, by your silence, I guess I'm okay to understand I should never give out extra credit points on tests or quizzes. Thank you for helping me understand that. I will be very strict about that. Love it. Love it, Maya. When I taught high school, I would give out extra credit points, but they had 0% effect on the grade. It was kind of evil of me, right? Like I would try to trick students into putting in a little more effort, or, you know, working a little harder to maybe get a better grade or learn something a little more by offering extra credit. And you know, if you say a couple points, that's actual change, right? This is actual change. So let's run a scenario. Let's say it's a 10-point quiz. If I give you 2 points, what percent change is that? So let's say, well, yeah, just what percent of the quiz is that? That's 2 over 10, right? Which is 1 over 5, which is 20% of that grade, 0.2 or 20%. So if I handed you 2 points, 2 extra credit points on a 10-point quiz, that is a 20% increase in your grade. That's a significant change. What if I give you 2 points on a 100-point quiz? Let's see. I divide the top and bottom by 2. That's 1 over 50. Boy, what is 1 divided by 50? Does anyone remember this old school thing? Multiply 50 by 2. That's 100.2. Yeah, that. Wait. Oh, I really screwed that up. Yeah, 0.02. There we go. I put 50 and 10. I wanted. Where's my eraser? I wanted 50 and 1. Oops. Easy there. Here we go. Thank you, Jennifer. So 0.02 to that. This, by the way, don't worry if you don't know what I'm doing here. Just divide 1 by 50 and Desmos. Okay, so that's a 2% increase. Now you might still feel like that's significant, right? Because 2% could be the difference between a passing grade and a failing grade, or a 4.0 and a 3.0 or 3.5. But it's certainly less significant here. So it's not a big deal. It's not super helpful. The more points a quiz or the more points an assignment is worth. That's what we're trying to get at with this relative change versus actual change. someone could trick you into thinking that large amounts of change is significant when compared to what it already was, it's not significant at all. These next questions, he's wanting you to, he's trying to highlight the language we use. So we're supposed to write a sentence that describes what exactly the given statements mean. So the relative change in my budget was 7% compared to last year. So this is a 7% increase in the budget. Meaning maybe they got a 7% raise, maybe they're spending 7% more. I don't quite know. It's kind of vague here what's going on. But the thing to keep track of is when the number is positive, we use the word increase. Whereas down here, the relative change in enrollment this year compared to last year at my college was negative 3.5%. That means there's a 3.5% decrease in enrollment. That's bad news for a university or institution that requires students to fund the programs like Jackson College. So again, note here we've got a negative number that shows up as decrease in the English language or in when we write out the sentences, and we don't write the negative on the number. Here we're supposed to use the term relative change or percent change to describe what's going on. So Apple's profit in 2016 was 14.4% lower. So that's a relative change of negative 14.4%. Relative change in profit for Apple, blah, blah, blah. And retirement fund was 5.5% more, so relative change of 5.5%, that kind of thing. Let's get to some more of the calculations. I want you to do this one. And I'm going to give you 5 minutes to try it. And then I want you to type your answer. Set a timer for 5 minutes. I'm talking and I'm muted. I said, okay, love it. Anyone want to talk about, anyone want to explain how Maya got 466 million in 2020? Or 461? million.
So I got 465, 450,000
How'd you get that?
by using a calculator to add 7%.
How'd you get the 7%? Not saying anyone's wrong yet. Go ahead.
435 million times 0.07.
Love it. Okay, so this gets us the amount of change, right? So this is the relative change. This would be the amount of change. So let's jump here. 435 times times 0.07 gets us 30.45 million increase. So they should be spending an increase of 30.45. If we add that to the 435, we get the increase. So Maya, you were right the first time. I think if we round it to the, let me see what you wrote again. Oh, that'll do it. Yep, you put in 6%, you're going to get a different number, 100%. Yep. Okay, so this is what the new value should be. So let's do a quick calculation. This should be the new value for 2020. This should be the old value. If we did new minus old divided by old, we should get exactly 7%. Why not check it? Let's see, 465.45 minus 435, all that mess divided by 435. Hey, it's exactly 7%. So that's the relative increase, relative change from 2019 to 2020. Note what it's for. It's for interstate highways, money spent to improve interstate highways. I also noticed the context here. Budgets are approved each year by Congress, and they're proposed by the president, right? Or the administration, I guess. So this is saying that there's an automatic increase from one year to the next. That's built into the law. Oops, that's your 5 minutes. Okay, so this is the new value. Awesome. So then we get this example problem, and our author says, well, it turns out, or what if it turned out that only 440 million is budgeted, not the expected amount. So here we could quick look at, well, what was the actual increase? So that's the difference between the 440 and the 435 million. So the budget is increasing by only 5 million. And then we could look at, well, what's the relative increase? What's the percent increase? So relative change, that's take this change amount, divide it by the original amount, and we get it's about 0.115 or 1.15%, way less than the supposed automatic increase of 7%. How are we feeling so far?
Decent minus the fractions.
Yeah, so I love it. You can hate on fractions all you want, but guess what? Just go to Desmos and let Desmos do all the fractions for you. As long as you type them in right, you're good. And I agree, fractions are very hateful. It's because they have an extra set of rules. Like, we don't like being held down by rules. And you first learn how to add, subtract, multiply, and divide with whole numbers. And then we're like, oh, hey, what about fractions? And you have to learn a whole new set of rules for how to correctly add, subtract, multiply, and divide fractions. That's why they're so hateful. Okay, so then check this question out. It says, a news article reports that this program has been cut by 5.7%. Notice it's a percentage. So this is some organization trying to say, hey, the current government is screwing up. They cut road improvements by this. Look at how terrible the potholes are around you. Elect me because I won't do that. I'll get us back up to the 7% increase. Sounds like a recent campaign here in Michigan, right? Many politicians have campaigned on the roads. And don't we call them the damn roads? Isn't that like a thing in Michigan?
I have a question.
Please.
Your paper says 5.7 and the book says 5.4.
Mine also says 5.4.
Oh, so I'm guessing who the electronic version was screwed up. Let's see which number is right. So the news article is taking this number as the new one. We're going to do the calculation and see what happens. See if we can get that number. So recall that the old value, the previous year's budget was 435 million. And I'm sorry, I've been sloppy with the millions. I've just ignored it. And then this new value based on what happened was the 440 million. So let's check what that number is. Oh, no, wait. What we're really saying here is that the old value was supposed to be 400, easy does it there, 465 mil, 465 point, come on, 65.45 million. That's what it's supposed to be. This is what it ended up being. Y'all get why I'm using those numbers? Okay, so let's go with that. Let's do our calculation. We've got our 440 minus our 465.45 divided by our 465.45. And let's see what that number ends up being in Desmos. Again, don't worry about these fractions. I think I did something super fast here that might be nice for you all, that might be helpful. You see how this is in a fraction. One of my colleagues taught me this. If you hit the division key, so you can, if you're someone that doesn't have a keyboard like me, you could open up this keypad, like if you're using your cell phone. Desmos is a free app that you can download. If you hit the division sign, you get an automatic fraction setup. So now we can do the 440 minus 465.45 divided by 465.45. Look at that number. This is approximately equal to negative 0.05469. Oh, in here, I thought I had it memorized. 54678 is what I should say. Okay, which is correct? Your textbook or my digital PowerPoint that I downloaded from the website? By the way, if we want this as a percentage, we need to multiply by 100. You may recall that that has the effect of moving things 2 decimal places to the right. So we get negative 5.4678. If we were around to 1 percentage decimal point, this would be negative 5.5%. The book is wrong. It's not. I looked up what he did because I wasn't quite sure what was going on here. And what he did is he rounded the difference, the change, to the nearest million. So he did this. So that 5.4 is correct based on his rounding. Okay, so not the 5.7. Note this is a relative change. Is this actually, well, so this is the calculation. So the news article is sort of correct, right? This says, why is this actually misleading? And we'll think about these things. It was supposed to be a 7% increase. It ended up being a 1.15% increase. And relative to what it was supposed to be, we get a negative 5.5% or 5.4% less than what it was supposed to be. Anyone have an idea of why this is misleading?
I think because they're saying that it was a decrease and it was actually an increase of 1.15. So they're saying it was a decrease from last year, which is not true.
Yeah, it's a total kind of lie. It's a 5.7% cut in expected increase, right? But really, the budget increased by 1.15%. And you know, we shouldn't talk bad about politicians, right? Like, I mean, maybe we should. I don't know. They're trying to make their money and they're trying to sway people different ways. It'd be nice if everyone was just honest and open and said, here's the facts, and we could all agree on those, right? Life would be so much easier. But this is a great place to note that numbers tend to lend credibility, and that people can lie really good with numbers. And so you have to be careful that's why math education, in my opinion, is so important. Because we live in a data age. And if you can understand how things are put together, you can cut through the misleading things and say, oh yeah, that is mathematically a correct calculation, but it doesn't accurately reflect what happened. Okay. I would like you to try this on your own. And why don't we try it on that worksheet that you're going to turn in on Sunday night-ish for the soft deadline to keep you rolling. And if you miss it, that's okay. Just make sure you eventually do it. So we're turning to the course pack, and we're going to worksheet 1.5 in the course pack. Ooh, coffee grounds. Ooh. Oh, come on. This is taking forever. This file was too big. There's that fun 1.4. Okay, 1.5. I went to, you can check this out. I went to like a transparency website and pulled up these actual numbers on spending. You can click this link if you download it, and you can see where I got my information. I try to find, oh, it doesn't exist anymore. What happened? Looks like I need to update my link. I try to use real data as much as I can, because that's important to me. So here, this says find the difference in spending. This should really say change. That's what we're talking about. And then here it says find the relative difference. This should really say relative change. All right. So I want to see you calculate those two things. I'll give you 5 minutes. Maybe I can get in 20 push-ups while you do that. Set a timer for 5 minutes. Okay, okay. Anyone disagree? Everyone agree with Jennifer? All right, all right. Just in case, I want to make sure everyone, well, okay. So Jennifer, I agree with your answer for B. I don't agree with that as an answer for A. Anyone got an answer for A? Love it, love it. That's the $40 billion, which is insane, like billions of dollars. That's crazy. That's so much money. I don't know if you hear in the news, like, hey, we sent another 360 or another $565 million in aid to Ukraine. It's hard to understand those numbers. When you think about that amount of money relative to the tax dollars that are brought in, that's like $0. Not quite. Maybe it's like 1%. Sometimes when you get to these monster numbers, it's really, really hard to wrap your mind around what's going on. Okay, yeah, oh boy, there's that. $40 billion in change. It was an increase. That's how much. I don't know if you all know what federal contracts are. If you work for the government, or if you want to make money doing government work, this is the place to do it, right? You're a private company that wins a federal contract. You don't want to actually work for the government because the pay isn't quite as good. It's from what I understand. Okay, excellent. $40 billion in change, $40 billion increase, 8.5% relative change relative to the previous year's spending. Let's see, Jennifer, let me look at your sentence and see if I like it as the answer for C. I don't know if that's what you, close. There's one thing missing for C. Do you all want to take a second and write out your answers for C? And maybe I should remind you, this is a very specific type of answer. I need the when, the what, and the how much. And I was grading of the 15 worksheets I graded, this was the most commonly incorrectly answered question. Love it, Jennifer. That was the only thing you missed in the previous sentence, is the time frame. Another place that I tend to get picky on this is when students just write spending. There was an 8.5% increase in spending. Spending on what, right? Like, it matters. People might have fights over what that spending is. So it's important we keep track of this, in my opinion, the specific details. So let me copy in Jennifer's sentence there. It's a perfect sentence. If you wrote it a little bit different in a different order, that's fine too. You don't have to start with the time frame. Excuse me. And then the how much, you could say there was an 8.5% increase from 2016 to 2017 in federal contract spending. Any order of those three things. Maybe I should highlight very clearly. Here's the when. Here, these two things are the how much. You're always going to be using the word increase or decrease. And here's the what. Excellent. Boy, we did the 1.5 worksheet. We do need to do one more thing from 1.5, and that is we need to talk about error and percent error. So it doesn't particularly matter how we calculate these things, what we do, what we subtract from what, but it will change the interpretation. So this is this is the standard way in the industry. I don't know if that's the right word. When statisticians talk about error, I think when engineers talk about error, you start with the estimated value and you subtract from it the actual value. I think it makes sense because you make the estimation first, then you go do your measurement or you collect your data and get the actual, and you compare how close were you. Like if you're in the construction world, you're estimating how much materials you need. You tend to want to overestimate so you have extra materials so you can finish the job, as opposed to underestimate, because if you run out of materials, you can't finish the job, right? So I stick with this language, estimate minus actual. This is the same idea as change. It's the same type of calculation. It's just we really don't have a time frame going on here. It's just what you estimated and what you actually got. When you do it in this order, if you get a positive number, we call that an overestimate. That means you guessed more than what it actually was. If you get a negative number, we call that an underestimate. That means you didn't estimate enough and the actual value came out to be more. Where this shows up in the news, like monthly, is the jobs report. People will predict what they think is going to happen. Oh, there was a 10% increase in employment, or there was a 1% decrease in unemployment. And then the numbers get crunched and calculated and they get published, and we get the actual amount based on the studies. And then, you know, if it's good news, the market goes up and everyone's happy. If it's bad news, people sell their stock and the market drops, all that kind of mess. So we can talk about error. That's just the amount of error. And then the more important one is the percent error. This is how we could talk about how good of an estimator are you, or how bad of an estimator. And I like the language. It's the same exact formula as percent change and relative change, except that it's difficult to use the language of new and old, again, because there's not really a time frame. So I think you should stick with estimate minus actual divided by actual. Those are, I think, a little easier to identify. Okay, so our author has us go through doing some carpet buying. So we're doing a construction example, and we'll look at the picture in a second. I already answered this one, right? When you're buying carpet, do you want to overestimate or underestimate, and why? You want to over, so you have enough to fill the room. Okay, so we start with this. A carpet installer estimated that 24 2/3 square yards of carpet would be needed for this bedroom and closet. That's the estimate. We're going to set that aside. We're supposed to calculate the area in the bedroom. Anyone remember how to calculate area? It's a really old school problem.
Well, length times width.
That's it. Just length times width. Now I want to be pretty well. So then the question is, what's the length and what's the width? I think a pretty standard definition is that the width is the wider one and the length is the longer one. I don't know, but it doesn't actually matter. We could call this the length, we could call this the width, or we could flip it. Doesn't matter. The only place I've encountered this in the real world is I sell stuff online. And I think it was Etsy, where when you put in the dimensions of a package, the length had to be longer than the width, or vice versa. Like it mattered to Etsy what you identified as the length of the width. eBay doesn't care. USPS doesn't care. They define length, width, and height, and you can put the numbers in any order and you don't get any errors. Okay, the other thing I want to note here is this idea of square yards. You might be super familiar with this. That's awesome. This is typically how we notate it, an exponent. What this means is yards times yards. Oh my goodness, it said it right here. So, what did y'all get it yet? What's the area of the bedroom? Note the units there. It's very important that we've got that in square inches. Closet. Insert a cameo. Got it. 64 times 50. And then it says each doorway entry, so here and here is 30 inches wide and 4 inches thick. That's interesting. Does he mean length there, I suppose? And so for this closet, we're thinking of this little part being 4 and this part being 30. And over here, we got the same idea. This doorway here is 30, but then it says we're only going to do half of it is going to be carpeted, because then there's going to be something else, I guess, on the other side. So this little length is half of the 4 inches. It's 2. So the area here is 2 inches times 30 inches, which is 60 square inches for that doorway. And then here it's 120 square inches. I hope that's okay. I just did, you know what? I could write it. I don't have to be lazy. How are we doing? So our job here is to figure out the total carpeted area, which if you think about what we did, we just calculated the area for 1, 2, 3, 4 rectangles, add them all together, and we get the total carpeted area. So here's the big bedroom. Here's the closets area. Here's the little doorway, the half doorway. And then here's the full doorway. Whatever that number is our square inches. $26,676 square inches. So we need that many square inches of carpet. How are we doing? Is everyone doing okay? We haven't done any estimating the actual stuff. Well, actually what we're doing now is we're calculating the actual amount to work with this estimate, which every time I do this problem, I think to myself, why wouldn't the carpet installer just go in and measure this and calculate and get the actual amount by measuring? Why would you estimate it ever? Maybe time? I don't know. I'm not a construction person, so I don't like do all that stuff. I worked for a guy that had his own construction company, and it was awesome. It actually looked so awesome what he was doing. He had his spreadsheets with all his estimates of things. But I always wondered, why wouldn't you just actually measure it? So, okay, here we get a problem that goes back to 1.4. We are to convert the total carpeted area to square yards. You see why, right? the estimate was in square yards, we measured in square inches. So let's take our 26,676 square inches, and let's think about how in the world could we convert this into yards? What do we know about inches to yards? Isn't 1 yard equal to 3 inches? Ooh, not squared. Am I right on that?
1 yard is equal to 36 inches.
Oh, now how in the world did you get that? How many yards?
1 yard is 3 feet,
Mm,
right?
I'm only a little bit embarrassed right now. So 1 yard equals 3 feet. 1 foot equals 12 inches. So yes, if we had to take these inches and basically we multiply these two together and we get 1 yard equals 36 inches. Thank you, Maya. Boy, I was about to do that really bad. Okay, now check this out. If I do this, will I get the right answer? I'm going to do something strange. I'm going to write the square inches as inches times inches. Now notice when I do this, if I multiply by this conversion factor, which is what we've done, I'll only cancel one of the inches. Y'all with me? So I have to do this twice. So that these inches will cancel with those inches, and we'll be left with yards times yards, which is square yards. How y'all doing? Anyone's minds blown yet? Here we go, 20.58333333 forever. 20.583 repeating yards squared. That's the actual area of this carpeted spot. So let's compare that to the estimate, 24 2/3 square yards versus 20.583 repeating square yards. Now, Mike, I'm totally with you on this. Look at this gross fraction, like what's up with that? Let's fix it. Remember that 24 2/3 is really 24 plus 2/3. So there's our number as a nice decimal. 24.6 repeating. What did our carpet installer do with their estimate? Was it an overestimate or an underestimate? While you all are thinking about that, I'm going to write out the percent error formula here, and we're going to go ahead and calculate the percent area. Then maybe we can answer that question. So I'm going to do estimate minus actual divided by actual. Is anyone bothered by the lines over the 3 and the 6? Oh, here's some stuff. Oh, Jennifer, you were typing things over under. Which one is it? I think so. So I hid my tool so I couldn't see you. You all typing. My bad.
It was, okay, what was the question? Okay, so the professional estimate was over. I looked at my thing wrong and I read 25 instead of 20. That's why I changed my answer, and then I wasn't changing it back again.
Nice. Hey, it's cool. Over under. That's a cool sound. Yeah, they overestimated. Good. Let's do our calculation here now. So these numbers are unrounded, right? So I can do this. I can do this thing where I do Control C, Control V, minus Control C, Control V. Oops. All that divided by Control V, and there's my actual, there's the most precise value for the percent error. It's approximately 0.19838, which is, we could say 20%, we could say 19.8%, we could say 19.84%, 19.838%, whatever we want. But that's, there it is. So they estimated his overestimate was 19.8%. Okay, so then we get asked a couple other questions here. I'm interested in, I like this question. So I don't know if you don't realize this, but when you buy carpet, you pay for the estimated amount, not the actual amount. So if the family owns the house and picked the carpet and it costs $28 per square yard, how much would they have paid? Note, this is a unit rate. $28 per 1 square yard. And we just calculated that the yards we're using here is the 50 point, what was it? 50.583. Repeating over and over. And this is yards squared. That one's the over 1. So if we do this multiplication using our understanding of canceling out units using dimensional analysis, we'll get the cost of the actual.
Shouldn't it be 20.583 yards squared?
Yep, it should, because we're doing the estimated, not the actual. So it should actually, well, it should actually be 24.66666 forever.
Okay,
But you're right that I think I even wrote that number down wrong, didn't I?
yeah.
So it's like double wrongness. All right, so I'm getting, it's going to cost them $690.67 to purchase the estimated cost. So the author says, okay, let's take the actual error we estimated to find the dollar value of wasted carpet. Notice this doesn't say percent error, it says actual error. We didn't calculate that anywhere. I'll calculate it right here. It's the actual, it's the estimate minus the actual. So we're getting an extra 4.083333 forever yards squared. If we multiply that by the $28 per 1 yard squared, we'll end up with the overpayment we made. So copy and paste that value times 28. Ooh, $114.33. And a random 5 right at the end. How nice is that? It's because of that 4. It's also strange there. Oh, that's because of the 7. Okay, so $114.33 approximately. Wasted. That's a really cool Lego set right there. You could get the Viking ship for almost that much. You need $5 more. You can get that Viking ship. I don't know how you like this guy's talk. He says, according to the internet, which knows everything, a good rule of thumb is to plan for 5 to 10% waste when buying carpet. How did our estimator do? Not great, right? Because they're above that. They're at the 19.8%. So they're almost double the wasted. Well, if we use the lower end, they're double the wasted amount than what really they should be at. So not great. Okay, any questions? You are going to use, we're going to skip this other stuff because then he wants us to redo everything but in feet, and I'm not very interested in doing that. You're going to use this error stuff. Oops, I guess I closed the project. Let me open again. In your project, right here. Now I said calculate the actual, and it really should say change again. I swear I changed that. And the actual change here, you're to interpret it, and I should really say the percent error in this part of the project, because it's you have estimated a value up here in your project of how much time up here you estimated how much time you were going to spend doing something. I think you should look at your screen time, or look at your sleeping time, or those of you that are parents, how much time do you spend with your kids, or something that isn't fixed. Like class time is not there's not much variability in that, I don't think. You either go to the 4 hours a week or 15 hours a week that you schedule for class, or you don't. Do something that's more interesting. And then you're going to calculate the actual amount of, I guess this should really say error, between what you estimated you were going to do and what you actually did. And then calculate what percent off were you. And then you're going to interpret these in context. And that's the when, the what, and the how much. But when it comes to the percent error, there's not a when going on there. You're just saying the percent difference between my guess or my estimate and the actual value of this context is this number. I was above or below. So task 3 is that error stuff. Okay, I want to pause here and ask you all to ask me questions about worksheets that are due. Does anyone have any questions, any of the worksheet problems that they got stuck on? Like, did you get stuck on anything in 1.4? Or did you get stuck on anything in 1.3? Or 1.2? Because at the beginning of class, when I say, are there any questions about anything, I'm really thinking, was there any problems on the worksheets that are due, upcoming, or already due that you tried and couldn't figure out? And I'd love to help you. I'd love to spend some time on that. But I don't know that I've made it clear that that's what that time is for, the beginning of class or the end of class. And I want to give you that opportunity to ask those questions. You just have to have a little bit of courage to ask them. And trust me, everyone will appreciate it if you ask me, even the people viewing the videos that aren't here. So does anyone have any questions about any of the assignments that are due? Worksheet problems, ALEKS problems, lesson check problems. Oh, we should also, while you're thinking of that question, I'm going to look up the lesson check for today's class for what we just did.
After you're done with that, could we go over 1.4 question F?
Yes, most definitely. Thank you for your courage, Cameron. Love it. What were we looking at? 1.5 lesson check. Oh, and I learned something, you all. I need to show you this. Those of you that use the Alex textbook, and remember how I said it was so awful to navigate it? It's mostly because I didn't take the time to learn how to navigate it. You can use the search button to find the lesson checks very easily. We'll do that. Let's do, well, Cameron, let's do your question. So question F on the 1.4 worksheet. Yeah, okay. So first, let me just write down an answer to question E. One correct answer would be 62 centimeters of model to 25.2 meters of real life. Or another acceptable one is 25.2 meters of real life size AT-AT, which doesn't actually exist, compared to 62 centimeters of model size. So I want to make sure everyone understands conceptually what's happening here. What I'm saying is this is a toy that I can build, and it stands like this tall. I don't know, 62 centimeters tall. I can't sit inside this because it's too small. I'm way taller than this little thing. But in the Star Wars movies, they built one of these that thousands of people could sit in, and it's a big assault vehicle, whatever. So there is a potential world where there's a life-size one that you could climb inside and drive. And so I'm saying, I actually went online, you can check this out. The actual dimensions of the real life AT-AT is 25.2 meters tall. So what we're doing is scale model, tiny scale model to really big life-size model. That's what this is. And then I tell you, oh, you know what? There's actually a smaller AT-AT that Lego builds. This is the number for it if you want to look it up. And it's 18.9 inches tall. If we were to take that small model, that mid-size model, and create one that you could climb in and drive, how big would it be? How tall would it be? Well, we're going to assume, what I'm asking you to assume is that these values are valid for, it's the same scale between the large AT-AT and the mid-size AT-AT. Okay, so note a problem first. This is in inches and our conversion factors are in centimeter meters. So the first thing we have to do is convert the inches into centimeters. I think we could convert these into inches, but that's more work. So I'm going to do my conversion factor. I'm going to pause and ask you what should be in the denominator, the bottom of this fraction I'm writing over here.
Inches.
Love it, because the inches will cancel with the inches. That is the entire key to all of these problems. What's in the top, what's in the bottom? Make sure the ones that are there are the same thing so they cancel. You all like the term diagonal from each other because they are diagonal. That works too. That's okay. You can say that. As long as you keep track of that and you write it down, in my opinion, you should be able to see it after enough practice problems. Also, this is really tricky stuff. So you know, don't feel bad if it's a struggle. All right, let me get what this is. 18.9 times 2.54, I get 48.06. So what we've done is we've said that the model AT&T is 48.06 centimeters tall. We've just taken the inches that I kind of meanly gave to you and turned it into centimeters. Now we're going to convert this into life size, a mid-sized AT-AT using one of these two conversion factors. So which one do I need to use?
25.2 over the 62 centimeters,
How did you know that one?
because we have to keep the centimeters diagonal from each other.
Muscles. Yeah, you got it. That's it. We just want these things to go away, so that's how we know which one to use. The centimeters of the model are in the bottom, and then the meters of the real life size thing are in the top. Now, I know one thing that makes this super confusing is the fact that we have meters and centimeters here, and you might want to convert the centimeters into meters or the meters into centimeters. You can do that, but you have to keep track that they're different things that were measured. So the units of these, the meters and centimeters, don't particularly matter as much as the life size versus model size. That's what matters most. All right, so multiply away here. We'll do it this way. That was times the 25.2 divided by the 62, and it will be 19.51 meters tall, if my calculations are correct. Yes. And that's meters of the life size thing. Did I round that correctly? I did. Okay, any other questions on any other worksheets or any other problems that anyone got stuck on? And I want to reiterate for you all, first, number one, I love you all coming to office or tutoring hours, 8:30 to 11. They're not really well attended. I've had maybe 3 people over the last 3 weeks, maybe 4. I love that. Please come in person if you want. I'm in JM 253 on Tuesdays and Thursdays, always online Tuesdays and Thursdays, or Mondays through Thursdays. Please make use of those times to work on anything you want, ask any questions you want. But I also want you to know that this class time is for the same thing. That's why it's scheduled. So you can come talk to me and ask questions, and it's just this class that gets to do that. No other class comes here. So make use of that. Please feel very comfortable saying, you know, I couldn't do this problem. I don't get it at all. Let's do it together. If you asked to do every problem in the worksheet, I would probably do it, depending upon how much time we have. Just saying. Okay, cool. Did everyone get number 2?
I was actually just about to ask you to.
Yay!
So
Okay.
so what I have, like, I don't have an answer, but I kind of just wrote out what they equal to, kind of. So like,
Okay.
I have 1 marathon equals 26.2 miles, and then I have 1.61 kilometers equals 1 mile, and then 10 kilometers equal 1 marathon. And I wasn't exactly sure where to go from there.
So you might have said it wrong. 10 kilometers equals 1 10K race, I think is what you want to say there.
Okay.
Instead of marathon, which is, you probably didn't write it. Yeah, good. Okay, so excellent. We have some options. What we want to do in the end is say how many of these, or sorry, wrong one. How many of these equal one of those? That's the end goal. The problem is we've got like we've got different lengths between these two. So either we convert the marathon distance into kilometers, or we convert the 10K distance into miles. Doesn't matter which. By the way, you'll get different answers if you use different rounded conversion factors. This one's perfectly fine. You could also say 1 kilometer equals so many miles. You'll get a slightly different answer. Totally okay. It's just because of the rounding. So what do y'all want to do? You want to do the kilometers to miles or the miles to kilometers?
I'd rather do it in miles.
Let's do it. So if you like doing it piece by piece, we could write this all in one long string, which I sometimes think is more confusing. We could just take this 10 kilometers per, let's call it one race. Let's call this thing the race instead of the 10K race. I think that also gets confusing. And we have to multiply it by a conversion factor that turns the kilometers into miles. What should we multiply by?
The 1 mile over 1.6 kilometers.
Do you see that pattern that I talked to you all about? Killing it, Cameron. Good job. If the units are one in the top, one in the bottom, they cancel out. Now, the multiplying might be tricky. Remember, it's top times top, bottom times bottom, but you can type exactly what you see there in Desmos. 10 divided by 1, well, not that, times 1 divided by 1.61. There we go. If you run a 10K tomorrow, you will have run 6.21 miles approximately when you run that 10K. Okay, so awesome. We've got that there's 6.21 miles per one 10K race. So now, let's see, now we can work with our one marathon and our 26.21 miles. Now, Jennifer, this is where I think you were the one that said last time, I don't write out all this crazy work that you do with all these crazy units. I just know to take this and divide it by this, and I get my result, right? If I'm remembering correctly.
Yeah, that's correct.
And I'm just totally on board with that. Crush that. Sometimes for some people that have no idea how to do any of this, the structure here, I think, helps, and this pattern of canceling units, I think, is helpful. I could be totally wrong. So we want this to be how many races are in one thing. So if I were to write this out, I would do one race over this. And I'm going to get the number of races per marathon if I multiply this out, which is really just 26.2 divided by 6.21. 4.22 races per marathon. I'll put the 10K back in now, 10K races per one marathon. How do y'all feel about that?
That makes more sense. I think I kept getting hung up that there was like 26.2 miles over one marathon, and then you're timesing it. So like the race was diagonal to the marathon. I wasn't sure what to do with that.
Right, you wanted them to cancel, and that's where I think Jennifer's thoughts are really, really valid, because it's weird to think that way. Because especially the way I phrase it, I said, how many 10-kilometer races are equal to one marathon? This is the answer, and this fraction, by the way, is another conversion factor. This is equal to 1, this fraction. So now we can convert, like, does anyone heard of a century? I don't know if anyone here's a hardcore runner. A century is where you run 100 miles in one consecutive race. Usually it takes like 16 hours. I met a guy that did it, and he said, anyone who runs a century, it's a mental game as much as it's a physical game. He's like, if you think you can't run the race, you won't run it. You won't finish. And you also like go to the bathroom in your shorts and you fall asleep while you're running, and it's insane. There you have it. Okay, other questions? I'm about to forget to do, oh, go ahead, Maya.
Can you please go back to worksheet 1.5
on 1B. Because I got a different answer than you. And I don't know why.
Is it how you typed it in your calculator?
It's because
Okay, you picking up Amari? Okay, okay. Bye, Amari. See you later. Okay.
I did it wrong. I divided by 5.10.
Okay, I'm so glad you mentioned that. Because that's a key thing to these formulas, is that what you divide by must be what you subtract by.
Uh-huh.
Okay, thank you.
You are welcome. Laquita, I muted you. I hope that's awesome. You're picking up your kids. I gotta go do that in 20 minutes. Did you, I muted you, but did you have a question that you wanted to ask? I always feel bad when I mute someone because I don't want anyone to think I'm upset at them, because I'm not at all. Any other questions, y'all? Okay. Interrupt me if you have one. I was going to show you all this cool thing I found in Alex to help with the lesson checks. I was helping a student find it, and I was like, oh, well, why don't I show everyone this? So for those of you that didn't purchase the physical textbook, and there's supposed to be a Bibliu textbook, but it's not. I don't know. I don't think we're ever going to get it. There's problems. So remember where the ebook is. It's here. Hopefully everyone's good with that. Here's the beautiful thing. For the 1-5 lesson check, you're supposed to do question 8 on page 83. Well, instead of scrolling around and looking for it, it is the modern era, right? You can search these electronic textbooks. And so just type in page 83 in that little search bar, and it will take you directly to that page. And now all we have to do is find question 8. Here it is. Not everyone realizes this, but when you buy carpet, blah, 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 how much would they have paid? And our answer from today was, wait. Where is it? Right here, $690.67. Here is the lesson check for 1.5. I want to explain my rationale for lesson checks. I think students often want to skip going through the textbook work. So I put in these lesson checks to try to get you to work through the problems in the textbook, because that's the learning part. And then the practice part is the worksheets and Alex. And then the unit projects are the demonstration that you learned it, and the midterm and final exams are the other demonstrations that you've learned it. So you kind of have like 2 ways to show me you've been learning the material, and you have 2 ways of practicing, and the lesson checks are to try to keep you to work through the book. I know there's a lot of students that just find the answer to the lesson check and don't do anything in the textbook, and that's fine if you're able to pick up the material, and if you feel like you're learning and feeling supported. Okay, boy, we're done a little bit early. We probably could look at 1.6 at scientific notation, but I think we'll save that for Monday. On Monday, we're going to finish that section, which will finish Unit 1, and then we're going to do an overview of everything you are supposed to learn from Unit 1, talk about the project some more. Maybe I can show you some example projects so you get an idea of what it should look like. And then on Wednesday of next week, we'll be starting Chapter 2, Unit 2, which is the most algebra-like stuff in the course. I don't say that to scare you. I say that to get you excited, because it's awesome. And we will do everything in Desmos. everything. Did it change? It should. It will change. Yes, I will change it right now. Thank you, Jennifer. Yeah, I will change it right now. Okay, so I think I will stop the recording in case that